Junior Cert Trig question from 2015. The triangle STU has sides of length 4, 7 and x. Find the two values of x for which the triangle STU is a right-angled triangle. Give your answer in third form. So quite an unusual question. So we have two values of x that gives me a right-angled triangle. Okay, well the first thing I'm going to do is to draw two right-angled triangles. I'm drawing my right angles. Okay, so the triangle STU has sides of 4, 7 and x. Okay, find the two values of x for which the triangle STU is right-angled. Give your answer in third form. Okay, so the bit of theory that we need to know here. Okay, longest side on a right angle triangle is always the hypotenuse. And the hypotenuse is always opposite the right angle. So the largest angle is always the 90-degree angle. Okay, so in a triangle, the largest side, the largest length side, is always opposite the largest angle. That's always the largest angle, which means the hypotenuse is always the longest side. In the same way, the smallest side is always opposite the smallest angle. Okay, don't know which of these would be it yet until I do some calculations, but I just know that the smallest angle is always opposite the smallest. The smallest side is always opposite the smallest angle. Okay, why am I telling you this? Well, when I see three sides, 4, 7 and x, okay, I think maybe 7 is the largest side there. So maybe I could draw the triangle that he was 7 and he was side 4 and he was side x. So in that case, 7 is going to be the longest side and x is going to be smaller than 7 because the hypotenuse is always the longest side. In the same way though, x could be the longest side and maybe these two sides are 4 and 7. So that's a perfectly acceptable triangle. But what does not work is a triangle like this, where you put 4 here on the hypotenuse and x and 7 here. That can never work because the longest side is always the hypotenuse, so 4 is not the longest side, 7 is definitely longer than it. So that option of a triangle will never work. This one does, because in our calculations we'll make x be smaller. This one will work because x will be longer than 7 and 4. Okay, so that's why I gave you that piece of theory down the bottom, so that you wouldn't end up drawing that triangle I just rubbed out there in red. Okay, I'm going to clear out that piece of theory now. It's in the recording, so you have it. So take it down, make sure you know it, and let's work out the two values of x. Find the two values of x. So let's do this one first. Okay, so again, a right angle triangle, we only have sine, cos and tan, or Pythagoras' theorem. Pythagoras' theorem is all about the sides, because if you look in the log tables, they call all the sides small letters and they call angles big letters. So this is a side, side, side. This has got an angle in it, sine, cos and tan. So when I come over here, I'm side, side, side. I have no angles. So it makes sense then that I'm just using Pythagoras' theorem. Pythagoras' theorem tells you that the hypotenuse squared, how do I know that? Because in their diagram C is the hypotenuse, it's opposite the right angle. Hypotenuse squared equals the other two sides squared. So for this one I have drawn here my hypotenuse squared is equal to the other two sides squared. So 7 squared, 7 sevens are 49. 6 squared, or 4 squared, 4 fours are 16, plus x squared. Solve for x, I'm going to minus 16 from both sides. So I get 49 minus 16 is 33, is equal to x squared. I want the side x, not x squared. So the opposite of squared is square root. Square and square root cancel, and that's how you're left with just x the side. But it's equal to the square root of 33, which in decimal is 5.74. Okay, the answer says give your answer in Cert form. So I'm putting that into a bracket. That's how they want your answer, root 33, okay? Why did I bother changing it to decimal though? I just wanted to make sure my calculation was right and that the x value was less than the hypotenuse. So 5.74 is smaller than 7. That feels right. It's very hard to know from root 33 whether that's less than 7. So you don't have to write down this bit on your paper. You can just do it on the calculator if you want, but it's a good check to make sure that that side is less than the hypotenuse. Okay, so that's one value of x. Let's try this one. So my hypotenuse squared, so this time my x is the hypotenuse, is equal to the other two sides squared. And it doesn't matter the order I put it down in. So 16 and 49. You can see it's the same numbers as over here, just in different locations. So it's equal to 65, square root of both sides. X is equal to root 65. Okay, I'm just putting it as a decimal again, 8.06, to make sure that my hypotenuse is the longest side. And 8 is bigger than 7, so that feels good. But my answer, they want it in Cert form, and Cert is just a square root in your answer. That's all Cert is. It's another type of way of writing a number. You have fraction, decimal, percentage, Cert. So there's your two values of x. And that was that part B of the 2015 question.